Good morning. This is probably going to be an Ignite style talk. I think this thing is already preloaded to advance whether I want to or not, so this should be kind of fun. So good morning. Again, my name is KenCairn. I'm the City of Boulder's Environment and Climate Planner. And I thought I'd try to be a little bit playful today. That's one of the reasons why I was just going back to see what in the world I called my talk. In fact, the original, Robert edited my original title, which was Sustainability, Resilience, and the Message of Lao Tzu Towards a More Realistic Cultural Narrative in a Climate Change-Driven World. And I thought, that's actually the joke to begin. You know, as a speaker, you're supposed to start with a joke. Because the real title of this talk should actually be How Climate Change Has Helped Me to Overcome My Hatred of the Term Sustainability. So I'm going to cover four broad areas this morning. The first is this problem I think we have in terms of the term sustainability and a few thoughts about that. And the second is to talk about climate change and to make the argument that climate change is not a problem. I'll get back to that. The third is that I'd like to give you a few dispatches from the kind of frontier around the work that's trying to integrate sustainability and resilience. And finally, I want to just close with a few ponderings with you about what it takes to create a strategy to take us beyond where we are. So to begin, sustainability. I don't know how many of you have had this kind of experience. I was really excited at the beginning of my career as sustainability started to get very popular as a term, and it seemed like, wow, this is kind of like part of the Green Revolution. And then after a while, there was just some sort of growing sense that there was something sort of fishy about this way we were using the term sustainability. And I couldn't quite put my finger on it. I mean, part of it was, of course, the equity issue, that basic question of sustainability of what for who, right? But it wasn't just that. But I could never put my finger on it. And, you know, for lack of a better term, most of us were kind of stuck with this. And we even have a department that's essentially got sustainability in its name. And the breakthrough actually came for me when we were applying to be a part of the Rockefeller 100 Resilient Cities process. And we were trying to figure out what the relationship of sustainability and resilience was. And since we'd spent 15 years trying to get comfortable with the term sustainability, a lot of people in our organization were saying, oh, well, resilience is just something that's underneath sustainability, right? We're like, well, that doesn't feel quite right to me, but I don't know. So we did that kind of classic thing. I was going to try to do this on a board, but we don't have a board today. And I'll get back to this. Does anybody know what this is? Besides you. He was just there. Please, in the back. Newspaper rock? No, actually, well, I don't know if it has that name, but there's a name for this particular petroglyph. Does anybody know it besides Marcus? It's called the precession panel. So, well, I'll just give you a sneak preview of my argument here. I think there's two problems with the term sustainability. One is that it's based around this notion that we can create a stable, unchanging system. That's our desire as a species. Now, you got to give us, some slack here. Of course we want to create something that doesn't change, that's comfortable for us. That's just kind of natural. But it isn't actually how life works. And so when we were pondering this, what's the role of sustainability and resilience? And first we had it over here. It was like, no, it's not quite right there. It's really, sorry, I'm not supposed to stand in front of that. It's really something separate, so we put it next to it, and we said, well, what do these terms really mean? Well, sustainability is really about stability, how we create stable systems. And again, it depends on who's controlling that process, but ultimately that's what we're after. And then resilience is fundamentally about change. When Hollings and his group were working with this term and it was coming out of ecology, what they were studying was what happens to ecological systems when they are disrupted. And by the way, I think this is one of the problems that resilience is kind of trending in this way that sustainability had, which is like everybody's using it for everything. No. Resilience was originally intended to talk about when systems get disrupted. Not just when you're a little uncomfortable, but you're doing okay, but when you're completely knocked off balance. So it's about change. So we're like, okay, sustainability, resilience, stability, change, kind of a duality here. And then we thought, well, what if we put a big circle around the outside of this? And then I thought, oh my gosh, this is what Lao Tzu was talking about, 200 years ago, or 2,000 years ago, right? Because it's basically this dynamic dance between stability and change. That's life. And that part of our problem as a society is that we've been trying to create the system that does not change. And so, of course, what do you do when you create systems that do not change? You create more and more rigid things that when they fail catastrophically. So, what if it is a dance? And in fact, what if that's the point? And what if it's about how you learn to move between stability and change and actually use that point when you get knocked off balance to learn something so that you evolve to that next level? So that's the ideal, and I would say that's what evolution is. And of course, it can go the other way. And we are very much in a context where if we don't get this right, our whole systems as a species can go the other way. So that's my first problem with sustainability, is that it's based on a false premise that we can create systems that don't change. And thank God that resilience has shown up, and hopefully we give it its equal due as the companion to this process. My other problem with sustainability, and I think resilience has got this in spades too, is that we don't know how to prioritize, or we don't seem willing to say, this is a first order thing to do around sustainability or resilience, and these are great other things to do, but they don't necessarily all have equal weight. Because you know as well as I do that for a long time we've been talking about like, oh, that's really cool, that helps sustainability, and that's really cool, and that helps sustainability, but guess what? Point two, climate change is not the problem. Climate change is the symptom of a problem, which is basically an indicator that our systems are not sustainable. And I'll get to that in a second. But this is from the work that Marcus mentioned, others that ISET have done. And when I saw this, I was like, thank God, finally, somebody has actually been talking about in the resilience category that there are first order priorities. So that you really got to make sure that your energy systems and your ecosystems and your water systems and your food systems and your sanitation and communications remain online, or you get them back online quickly. Because if you don't, you have catastrophic failures that flow from there. It's just cascading failures above. So while we started our conversation in Boulder as we were starting to prioritize around housing, yes, that's important, but if those other systems fail first, you don't get a chance to have a conversation about housing. And I'll give you a practical example. In 2013, when we had the flood, we didn't lose our water, sewer, or power systems. What our community doesn't know is how close we actually did come to losing those. Our single one point of failure main for our sewer system was elevated 15 feet by a huge undercut that had taken place. If our guys hadn't been out there for 24 hours a day in the midst of the flood with backhoes trying to keep that thing from breaking, the whole sewer system for this community would have failed. Meanwhile, we have 2 water treatment plants. One of them had to go offline because there was so much turbidity in the water there was no way they could treat it. The other one up the canyon, Batasso, guess what? Power went off. One of the most unreliable circuits that Excel has happens to serve our water treatment system. That's helpful. That system actually also happens to be up a canyon where, of course, when it floods, the roads wash out. Not very convenient either, since our backup power is diesel. So we couldn't actually get diesel trucks into the water treatment plant. The only reason the water treatment plant stayed online was because we had some really brave employees who were driving ATVs across canyon trails with diesel tanks on the back to keep that thing going. So we almost lost 3 of these systems. And if we had, we wouldn't be talking about how great Boulder weathered the flood. We'd be talking about what a catastrophic failure that was. So the point I'm trying to make is there really are priorities. There really are first order high leverage things that you need to do first, not just in resilience, but in sustainability too. And that's why I'm going to argue now, the second point, that climate change is not the problem. And we have to get this right, because if we don't define the problem correctly, we'll direct a lot of our attention and resources to things that don't actually solve the problem. And thank God we're actually getting closer to identifying at least one of the primary problems in climate change, which is our energy system. Okay, thank God for the Pope, right? It's now safe to say burning fossil fuels is causing climate change. Huh? Literally, you look back to the dialogue, we weren't even saying that until about a year ago. It's like, Jesus. Okay, so that's one, but it's not the only one. It is the primary source of emissions. But our consumption patterns, of course, are dramatically contributing to this as well. And finally, but not at all least of which, and in fact the thing that we're going to have to spend a huge amount of resources and creativity around soon, is how we ally with our ecosystem friends, all the different forms of life that are going to try to help us pull a lot of carbon back out of the atmosphere. So, but today I want to talk mostly in terms of especially illustrating the sustainability issue around the energy path. And one of the first things I want to say is, boy, have we gotten the messaging of this one wrong for about 15 years. Like, we've been running around to people saying, my God, there's a climate change problem, and the thing you got to do is reduce greenhouse gas emissions. And then we, a couple of years ago, we came out and we said, now you've got to reduce them even more. I mean, Kyoto says like 7% by 2012. Now it's 80% by 2050. People are like, wow, that's really scary. Okay, we'll get on that. Now, what was a greenhouse gas again? Like, take this thing that we do not have a sense faculty to apprehend. I can't see it, touch it, smell it, taste it, in any way experience a greenhouse gas. And I'm going to tell you now, you've got to reduce it by a whole bunch. It's just a non-starter. Not to mention the fact that it's negative messaging. You've got to do a lot less of this. So I would say that one of the first things we need to do is get the messaging of this right and say, what do we want? We want a clean energy system. That's what we want. And fortunately, the emissions reduction that we need is about the energy level we want. So if you say you want an 80% emissions reduction, essentially what you want is an 80% clean energy system. Well, now that I can actually start to relate to. I can actually know that I'm a part of it. In fact, I can decide whether I'm going to put it on my house, put it underneath my house, drive it around. Those are things that I can participate in. So let's talk a little bit about how you would get there. Actually, because some people say, well, it was kind of nice when you were just talking about it in terms of emissions, because at least then I didn't know what you were talking about. Now you're going to tell me that I look around and everything I see that's using energy, 80% of it has to come from a clean energy source? Like, that seems completely preposterous. Well, it's not. It's not at all. But let me just start with where we are in Boulder. If I asked you, I should have gone back. Okay, you didn't see that slide. What proportion of Boulder's energy comes from clean energy sources? Did you see already?
30%.
Thank you. What do you think? Did you see already? Okay, stop. How about in the back? Did you see? How much do you think, how much clean energy does Boulder have right now? Sir? Yes?
Saw something about well over 8%, around 8%.
Okay, so most people would have answered around 25 or 30%, right? Because the thing we've been talking about for 10 years is the renewable portfolio standard, where Colorado was the first in the country to pass one. It was 10% initially. That was a huge deal. Then we got it to 20%. Now it's going to be 30%. Fantastic. But guess what? Electricity is only one part of this game. And so when we look and we did the analysis and we said, well, what proportion of our entire energy system, if you wrapped not only electricity, but natural gas and petroleum into it, what would it be? Now, I'll just note, for those of you who are somewhat statistically inclined, that you'll note that this is 2012 data. So here's my disclaimer. This is the only data we could get from Excel. In fact, we had to get this through Discovery, because they won't give us the detailed data that we really need to actually manage our greenhouse gas inventories. Because they're a little pissed off at us. You probably know why. We're trying to take them over in our local. So anyway, the point is, 7.5% in 2012. Now, some of you might say, well, wait, I heard Excel's putting in a whole bunch of wind farms, and so this is going to be a lot better, right? And so we actually went back through and we crashed the numbers for 2014, and what it turns out to be is if you add the 2014 wind farms that they put into their regional portfolio, Boulder's share tends to be 8.25. So we've got a little work to do. 8.25% is what we got about or so now, clean energy. You think, well, now we're supposed to get to 80%. You guys really are barking up a strange tree. But here's the interesting thing. First of all, know that most people who have been in this game say that the way you're going to get to this conversion in the time frames that we have with the technology that's available is you're going to convert most things towards electricity, right? Because that's the thing, that's the form of energy that we can create renewable energy in. So we said, well, how much electricity do we use now? Let me see if I can make this pointer work. Yeah, so about 225 megawatts is what we want to have moving through our electrical system at any moment to make all this stuff happen. So great. What about the rest? Well, we converted all the natural gas that we're using into an electricity equivalent. And we found that to be somewhere in the 35 to 50 megawatt range. And then we said, all the driving that's going around, how much electricity would it take to drive all of that? And by the way, one of the great things about electricity as a form of transportation is 30% more efficient right off the top. Because what? Remember, an internal combustion engine, it's burning things, all that heat, all that energy is lost. Not doing that in an electric vehicle. Anyway, the point is 50 to 80 megawatts. Now, what's interesting is we have a number for what Boulder's total energy budget needs to be. And this is, by the way, before a lot of very aggressive energy efficiency stuff that we've put in place, like the first net zero buildings by 2031 code in the country, the building ordinance for commercial and industrial. Anyway, a lot of stuff that will probably make this number a little bit lower. But the point is, here's the number. It was the first time we actually had a sense of it. Let's just say it's 350 megawatts of juice we need to do everything that we're doing. Now, here's a question for you in the back. How many windmills would it take to do 350 megawatts? And again, no right or wrong answers, just give me your guess that comes to mind. What do you think? No, the person right behind, the last row, the guy who's been coding in the back. What's that? 20. Okay, anybody else? 100. Anybody else? 5,000. Okay, so that's a great endpoint. So we got the 20. And so 20 into 300, it's what? It's a lot, okay. 5,000. So usually I get this like 500 to 1,000. Yeah, well the real number is most of the new wind turbines that are coming out are like 1.5 megawatts to up to 5 megawatts now. But let's just say 2. Let's just say 2. So 350 megawatts, we need 175 turbines. Now, I don't know about you, the nice thing about the number is I can count to 175. I can imagine 175. Now, we wouldn't want to do it that way because then we would still have, even if it's 5 wind farms out there, we would have 5 points of failure for our energy system. Or maybe 1, once it's all brought into one big cable that's coming into our country. In fact, country. We are a country, so what can I say? But the point is we can count to that number. But that isn't the way we would do it. So here's a sense of how we might want to do it. First of all, we wanted to figure out how much solar energy falls on Boulder. And so we just finished an analysis. We did it 2 different directions. We had NREL do it, and we had a company called MapWell do it. And in fact, if you want to go online, there's now a solar tool that you can go online. It's called MapWell, MAPDWELL, mapwell.com/Boulder. It's a solar capacity tool that anybody in the community can use. You can type in any address and go there. I was going to show it, but it's just really fun, though. You can go to any building in the community, see its solar capacity, see the carbon reduction, see the cost to put that system in. But part of what we figured out was how much solar do we have? And so this is the number for Boulder and just surrounding us, just on our rooftops, in our best and just the best aspects of those rooftops, it's 600 megawatts. That's not the parking lots. That's not a lot of the open spaces that probably could have it. It's not a lot of other places. So remember, 350, now 500. Now let's talk about wind. Colorado, 10th largest producer in the country, 2,300 megawatts, fantastic. How much does DOE say we can produce? 327,000 megawatts. Now, of course, we wouldn't want that many wind turbines everywhere, but the point is there's just so much energy. But wait, we're sitting, lying on a huge amount of energy. The average lot size for a single-family house in Boulder, 7,000 square feet. Underneath that, in the latent heat that is just the earth, using the same technology that drives your refrigerator, could extract 15 times the heating and cooling that the structures above it need. And if you used solar energy to extract that, you'd get a 1 to 4 return. For every unit of energy that you had used, you get 4 of heating and cooling. The point is, we have an abundance of energy. Our problem is that we've built an energy infrastructure that burns things instead of captures things. And that's the transition we now have to make. So that may sound lovely, but you might say, prove it. All right, so I'm going to give you 3 dispatches from the frontiers of the work that we're doing, and I'm going to show it to you in 3 different scales: household, sort of institutional, commercial, and then regional. So at the household level, EV, PV, EE, so electric vehicle, photovoltaic, energy efficiency. One of the important insights that we've arrived at in the last couple of years, now we've been running energy efficiency programs for 10 years, and one of the reasons, by the way, that we decided to municipalize is that after running one of the best energy efficiency programs in the country for 10 years, we realized we weren't even moving the dial in terms of emissions reduction. You still have to do it, but you're not going to get to this kind of transformation of emissions if you're only doing efficiency. You have to change energy source. And so the discussion with Excel, whether you municipalize or not, is to say, how are you going to take your portfolio in the next 30 years and make it 80% or more clean energy? Not 30%, not 40%. In fact, when we did the numbers to say how would Boulder get to an 80% emissions reduction, we had to go 100% clean electricity to make up for the amounts in natural gas and petroleum that are going to be so hard to convert. So that's the level of conversion we need to do. So, but one of the things we learned was if you just look at these things in isolation from each other, they're good. Like if you just put photovoltaics on, great. You just do energy efficiency in a home retrofit, great. You just get an EV, fine. But if you do them together, there are synergies that actually really drive this forward. So, a local firm that the city funded through a competitive grants program called the Boulder Energy Challenge came up with a model in which we could look at the household level, what it would look like if you did all of these things together. And in fact, there's a significant analytic model underneath this that can model which kind of car and how big your house is and how much your energy use is. But here's the point that I want to try to illustrate. So, average household is going to spend, in this case, in this house, this is actually a modeled house here in Boulder, they're going to spend about, what is this, $168 a month in natural gas, $94 a month in electricity, and about $95 a month to drive around. Then they're going to buy a car, and they're going to spend about $450 a month. So their total expenditures for this part of their energy assets, and this is, by the way, one of the take-homes, every one of us owns this energy system. We just own various parts. Here's the parts that this household owns. And they are spending about $807 a month to own and finance and operate that set of energy assets. Now you take that same amount of money, $807, and you invest it in a deep home retrofit, which then takes your energy use down enough that you can put a solar system on it that will drive almost all of its energy needs. And then you buy an electric car, and you finance that whole package. It costs the same amount of money, but here's the interesting thing. After the term of that loan, which is about the same as your normal car loan, 6 to 7 years, here's their energy expenditures. Then what happens? Zip. This whole area, savings. That's not only 80% emissions reduction in that household, that's not only energy freedom. No longer are you complicit with fracking and mountaintop mine removal and Saudi and any other kind of oil-related atrocities. You're making a lot of money. And guess what? You got a resilience system as a side benefit. If you put battery systems as a part of this, which this one didn't actually include battery systems. We modeled that out. You add the battery systems, it might add another 9 months to the loan term. The point is, at this point, you have a system that's standalone. That's the household. This will work the same way at other scales. The point is, look at the synergies. Okay, let's take a look at our water treatment plant. We're just starting into this project. So this is now taking it to the next scale up. So at this scale, they're using 5,000 kilowatts or so of energy. At this scale, we're using 250,000 kilowatts. This is one of the 2 treatment plants, and this is the one that went offline. We want to make sure that this plant doesn't go offline. We want it to be resilient. So we got a DOE energy grant to say, how would we make this plant more resilient? Now I'm going to take you into something kind of technical. Don't get scared, but I want to show you something that's really interesting. Here it is. How would you do that? Well, that plant's bread and butter are these, are these pumps. These are the pumps that move water through our community. Well, actually, there are 6 pumps, and then it has some indoor lights, and it has some outdoor lights, and it has some other things that it does. How do we keep those pumps operating if the power goes out? Well, you could do it by just putting in a backup generator. That's what this system is right here. And that would be fine. It's not very clean. It'll run as long as you have fuel. And it's just sort of your basic resilience package. But if you combine this with a system that's, now this was, so imagine that the original idea was big battery system, big solar array. Solar array is charging the battery is running the plant, the battery runs out of juice, oops, you put the generator on. But in this case, instead, this very clever company came up with these modules. These are all 50 kW modules. This is basically a 10 household power unit that has batteries and controllers. And it can be sized to have the amount of solar that feeds into it. That then, combined with a generator, basically makes this system capable of operating almost indefinitely. It eliminates demand charges for electricity that are the primary source of cost for this plant, and ultimately it makes this plant almost net zero. And we got resilience as a side benefit. We lowered our cost, we lowered our carbon emissions, and we got a full resilience benefit almost as a side benefit. Okay, finally I want to tell you this last story. Wind. So Texas, one of the biggest wind now producers in the country. Isn't it a great irony? You know, big oil state, but they're actually now one of the biggest wind producers. Something really interesting happened in the winter of 2014. Remember the polar vortex? That polar vortex caused power systems to spike in the southeast at a level higher than they'd seen almost ever. And that power spiking caused the grid to start to go down. They actually had to do rolling blackouts to keep the grid moving, except in the places that actually were served by wind. Because the natural gas peaking plants that are normally supposed to provide the backup power weren't able to operate effectively during those polar vortex. But guess what? The wind turbines were doing just fine. So you got this clean energy system, lowers your emissions, and oh, by the way, it actually makes you more resilient. Here's another really fun story. How many of you know of Mark Jacobson? Stanford University, the Solutions Project. If you haven't seen it, go online. Solutions Project. It's really cool. Mark is the quintessential engineer. He's just like, okay, you've got a problem, just tell us what it is. We're engineers, we'll solve it. Okay, Mark, the problem is that we need an energy system that's 100% clean. Really? How far? How big? Well, pretty much the whole world. Okay, well, let me start at the country level first, and then I'll work my way down to the states. So if you go onto this website, you'll see a clean energy plan for every state. So while they were down looking at Louisiana, I think, or it was maybe Mississippi, they were looking at the idea of putting in a big wind farm out in the Gulf. And then people said, oh, Mark, you can't do that because, you know, if you put wind farms out there, that's where hurricanes happen, and wind turbines are not designed to actually maintain themselves in Category 5 storms. He said, well, that's actually not technically true, but I'll humor you for this, and we'll just build out in a computer model a 10,000 turbine wind farm in the Gulf, and then we'll do something really interesting. We'll take a very robust computer model for a storm. This happens to be Katrina, and we'll run it into the wind farm, and we'll figure out how much of that wind farm would fail. And when? I mean, actually, it's a very good engineering study. Well, one of the things that Mark even didn't anticipate about that was that the leading edge of a Category 5 storm are not Category 5 winds. And so imagine this huge bank of wind that's approaching this huge wind farm, and it starts to hit that wind farm, and it's not, you know, destroying those wind turbines yet. And in fact, the wind turbines start to extract the energy from the storm, such that at least by the computer modeling, what happens is not a single turbine fails. But more importantly, they then analyzed what the storm surge and the wind speeds at landfall would have been, and it would have reduced the storm surge by 80% and the wind speeds by 50%. So the point is, I think, well, there's 2 points here. One is, we don't need just one climate plan, which is our old model. We essentially now, every one of us needs a climate plan. Basically, a sustainability plan that gets us a new energy system and a way to be more resilient in our lives. That's not going to happen by a single organization. That's going to be about collaboration. This is just as to say, the fantastic group that started locally. They're called the Climate Culture Collaborative, and their insight was we don't need any more climate action organizations. What we need is an organization that helps link all the organizations and individuals that are doing this work and actually narrate this fantastic work that's going on. And finally, I just wanted to say, bowing back to Lao Tzu, that maybe there is a place that these two things overlap, and that sustainability and resilience can find a common ground. We're seeing how that happens in the energy systems. There's lots of other places that might happen. I really appreciate the time this morning. Thanks for letting me indulge myself here. And so thank you for also all you're doing.